This is Surendran from Electronic Solutions. Today I'll be just taking you through some concepts of embedded systems and one of the NI hardware. I'll just give an intro to an NI hardware called as SBRIO 9626. Through which you can just dump your codes on FPGA and make it as a standalone. First, I'll just give an intro to hardware called as NI SBRIO 9626, which is nothing but an embedded based control and acquisition device integrated with a real-time process. Last week or some sessions back, you might have seen some DAC picture. You might have captured some data and you might have displayed it on your front panel in a graph indicator or whatever it is. The difference between that and this is that can't act as a standalone system. But whereas the NI SBRIO, which right now I'm going to give a session on this, will just have a standalone system, and it has got an FPGA with a user reconfigurable, and the clock speed here is 400 MHz, which is with industrial processor, and it has got a Xilinx Spartan 6 series. And in order to communicate with any NI based NI SBRIO or SBRIO, for your software requirements is you need to have a LabVIEW 2011.1 or a later. Without, you need to have a real-time module which is 2011.1 or later, and a LabVIEW FPGA module, and then NI RIO 4.1 or later. These are your software requirements. When you are moving into your hardware requirements, you need to have a SBRIO device, which is the one which I'm going to give a demo on that, and a 9 to 30 VDC power supply. This is not any external power supply source. This is already provided by NI Instruments. So always try to use the same power supply that is provided within your kit, and an Ethernet cable. This is for your better communications. And here are some specifications of your SBRIO, which has a processing speed of say 400 MHz, which is nothing but your clock speed, and your memory, which is a non-volatile of 512 MB, and a system memory of 256. And your FPGA, as I mentioned before itself, you have your FPGA as well as your Xilinx. The type is a Spartan 6 LX45. You can just go through the number of flip-flops or the inputs, all those stuff. Next, communication. When coming into communication, when you want to interact with your hardware from your LabVIEW, so NI provides different varieties of communications. It doesn't restrict only with the USB slot. It has got an SD port, a network, an RS-232, and an embedded CAN, where you can use it in, say, CAN is mainly used in automobile networks. And your network, which I'm going to use for today, is using my LAN cable network, so that I can even communicate to any devices that are present on networks. So SD port, it is nothing but your memory cards. And when moving into the specification of, say, digital analog, first I'll just give an intro to digital, which works only on 3.3 volt logic, and number of DIOs you have here is 4, which is DIO 0, 1, 2, 3. I'll just be I'll just show you a data sheet of that in the further sessions, and the current factors as shown here. And moving on to analog input, you have got 16 single-ended or 8 differential, and the ADC resolution is 16 bits, and sampling rate is 200 kilosamples. And as I told, digital IOs, the maximum volt that you can give is 3.3 volt and not a 5 volt of any supply. And when in analog input, the ranges is from say -10 to +10, within which you can go for 1 volt, 2 volt, 5 volt, or a 10 volt. So you have got 4 digital IOs, 16 analog ins, and moving on to analog out, you have got 4 with the 16-bit resolution and update rate of 336 kilosamples per second. As I said, for analog input, it works with a voltage of say -10 to 10. Even your analog output also works with a voltage of say -10 to +10. And these are the spec. If you want to know much more in detail what is the current consumption for pin or your total, you can just refer to your data sheets. Directly you can just give it as NI SBRIO 9626. And as I mentioned, this is nothing but your overall circuit board, I mean your SBRIO board, wherein these two black slots are nothing but your channels which will have analog in analog out, and DAOs. So these are just a battery, and this is nothing but your slot, and this is nothing but your power supply. As I told, you're not supposed to use the one from an external vendor. NI already provides their power supply which ranges from 9 to 30 volts. This board can intake of say 9 to 30 volts. This is nothing but your USB device, and this particular is nothing but for your network cable. That is nothing but my LAN cable. This white color button is nothing but your reset button. Towards its right you have 4 LEDs. So the first LED is nothing but your power on LED. So whenever you boot your device, initially this LED will be in on state. The next is status LED. Status LED, it will take using a normal operation. Third LED is nothing but your user LED, and the fourth one is nothing but your FPGA LED. As I mentioned, here you have 2 chips. One is nothing but your DSP processor. As I mentioned, the one more is nothing but your Xilinx Spartan X6 series. So these are the overall spec of your SBRIO. Now I'll just give how to configure your SBRIO, how to dump your code into an SBRIO. Like say right from scratch, how to start it. I'll just go for a demo session now. It's taking some time. So hope you all know what is a MAX, Measurement and Automation Explorer. So what this particular MAX will tell you is that it will just give you what are the hardwares that you have installed on your comp as well as your software. So what I do, I'll just open my MAX, that is Measurement and Automation Explorer. Here when I just look into my devices and interfaces, so these devices 6009, 8, NI USB 2901 are not a standalone systems. So before this I have used so many devices, so I am able to see all my devices in my list. This is for not a standalone system. Now when you just move into next, it is nothing but NI iMac devices. This will give you the cameras that are supported in your com. Like example, see, I use a Lenovo. So my Lenovo Easy camera is being detected under iMac. iMac is nothing but image acquisition. Now I won't find my SBRIO right now here. Why? Because since it is a standalone system or it comes under remote system, I'll be able to see my device under my remote system. So see here, you can find this, that is NI SBRIO 9626 with an ID. I won't be able to see this particular device in my devices. Now what I have to do is that initially I will have to configure my device with an IP. So what I'll do, I'll just go for my LAN cable, just go for the properties and configure. Initially I have just configured that my IP address right now is 169.254.66.101 and my subnet mask is 255.255.0.0 and my gateway is 169.254.66.1. Now the moment I am done with my IP address, I'll just give OK. Just make ensure that you have a proper IP address so that it will be able to communicate with your SBRIO. So here it is 169.254.66.101. I'll just give OK and then I'll just close. Now when I move into my Measurement and Automation Explorer, you can just find my IP address is also set to 169.254.66.100. Here these last digits should be different. When you open my LAN cable, it will be say 101, but whereas here 100. So the moment I am done with my basic settings, you will get a statement say like that system state is connected and it is running. This particular state determines whether you are connected with your hardware or not. If it is not connected, we just get it is not connected. So since I am done, I can just close my Measurement and Explorer. Now what I'll do, I'll just open my LabVIEW 2012. Since always try to have a practice of doing any VA under a project. So what I will do here, I need not create a blank project. Since I have a hardware in place, that is nothing but I have a target with me, that is SBRIO. I often will mention instead of a SBRIO, I'll just mention it as a target. So what I will do, I'll just go for a LabVIEW project. So the moment I click the LabVIEW project, what are the compatibilities or what are the RT based hardware that are compatible with my system, it will be available here. See, since I have installed my complete modules, I'll be able to interact with all these types of hardware. Right now I don't require any of those. Since I'm using SBRIO, I'll just directly go for single board RIO embedded system. This is nothing but SBRIO, which means single board RIO embedded system. The moment I have chosen this, see, a single board embedded system is a Serio with 96XX. What I'm using here is 9626. The moment I select this, I'll just give next. So here a system setup will tell, saying whether discover an existing option or create a new system. Already my hardware has been detected in my Max window, so I need not create a new system. So I'll just enable this option saying that discover my existing system. I'll just click this and give next. So during that time it will try to check whether is there any system discovered. So in Max window you might have seen NI SBRIO 9626. So now right now this is detected. The moment this is detected, just click on this and give next. It will now start discovering for the chassis. Now these are my complete data or my complete features. Now this is my SBRIO under which my chassis, under which I have my FPGA, that is my target. So here when you go through, you will have a complete connectors. How many analog in you have, how many analog outs you have, and how many digital IOs you have. As I mentioned here, you have 4 DIOs, 1, 2, 3, 4, and analog outs A00, A01, A02, and A03, and rest are all AI0. So what I will do, since I am done with this, I'll just give finish. Now the moment I give finish, now my project explorer window will open saying that this is a project and it is not saved. This is my computer, this is my SBRIO. My computer is nothing but my host, the computer on which I am working, and this is nothing but my SBRIO, which is being detected from my system. Now what I will do, actually I have already saved the project and I'll start explaining on this. Right now I don't want to start with a new project. What you can do is that you can just give Control S and save it in a desktop, say SBRIO test. I'll just give under this, I'll just give as 1. The moment I'm changed, it will just say project 1.lvproj. I'll just close this. Now in the moment you open this, you will find here 1, that is nothing but my LabVIEW project, under which I'll have 2 files. Now I don't want to start right from the first. I'll just tell you why is the reason. I'll just go with already one I have created. Here this is the project I have done. I'll just open directly that project. So under this project, same I'll have my computer and NI SBRIO, which is being detected from my system. So my chassis and my FPGA. So under this FPGA, I'll be getting my chassis temperature FPGA. This is a VA that I've already done. I'll just tell you how to do it. So these are my supporting dependencies, specification, all those stuff. Now what I'll do, this my computer is nothing but my host system. This is nothing but my RT. So whatever I write it in my comp, I won't be able to dump this. It will be processing in my OS, that is in my comp OS. But whatever I write in this, I'll be able to do that. Now what I'll do is I'll just take a small example. Now I'll just open this complete connector panel and start explaining. As I told before, The moment your chassis is detected, it will tell you the number of IOs that are compatible with your SBRIO. So what I'll do, I'll just click on this chassis temperature. So this chassis temperature, right now this VA, what I'm doing is that I'm trying to write it from my FPGA target. So what I'll do, what I've taken here is that what this VA exactly explains is that I'm just monitoring my chassis temperature. So whatever is my chassis temperature, I want to see that as my output. So my VA is done from my FPGA target, and what I'll do, I'll just run this. Can you just find these are the changes in your temperature? Actually here the temperature is in terms of Fahrenheit, not in Celsius. I'll just stop this. And one more thing here is that actually here you won't be finding any of the chassis temperature under connector input IOs. Here I have a separate onboard IOs, that is which will give me chassis temperature, FPGA LED, system reset. I've taken it from here and I have given an output and I'm processing here. So this is my FPGA VA. Now what I'll do, I'll show you one more example. This is my FPGA VA. So what I'll do, under FPGA VA, what I've taken here is that I've taken an analog input, I've created an indicator, and I've taken an analog output and I've created a control. Usually how to do here is that, example, these are your connector IOs. Example, you want to generate say a 5 volt of supply. So what I will do, generate is nothing but analog out. So what I'll do, before doing that, you can just style your window. So I'll just drag analog out 0 and drop it here. It means that whenever I run this particular FPGA based target, this particular, if I make any changes in my front panel, whatever changes, that will directly replicate into my FPGA board. So what I'll do, I'll just go here, right click, create a control. So this is how you can just add your inputs and outputs. Likewise how I did for this. Now what I do here is that whatever voltage I am generating at A01, that is I am generating analog out, that should directly replicate into my analog input. So what I have done, I have taken my inputs, outputs, and I have placed it in my FPGA target, and what I have done, I have given it in a while loop. Why? Because I want my system to run continuously. So what I will do, I'll just delete this. I'll open my complete panel. Now what happens here is that whatever voltage, say if I generate say a 5 volt, that should directly replicate into my analog input. In my hardware connection, how I have given is that this is nothing but my analog out, which is pin number 28. So what I have taken, I have shorted this with this. So whatever voltage I generate at analog out, say some X voltage, the same should replicate in analog in. So I have taken a probe or a RMC pin and I have shorted pin number 28 with pin number 2. Why? Because AI0 is to pin number 2 and A01 is pin number 30. So I'll just short this pin with this pin and this ground with this ground. The moment I am done with this, what I'll do, I'll just save 1 second. The first time whenever you run your FPGA VA, initially it will take say 5 to 7 minutes to compile its code. I can't be showing all this because it will take too much of time, say it will consume almost 7 to 8 minutes. So what I've done, I've already compiled my VA, but I'll just show you how it works. I'll just run this VA right now. Okay, it is compiling once again, but let me cancel this. Instead of that, I'll show you one more example which I have already done. Let me take this same chassis temperature. As I told, it is the same principle. I'll just run here. The moment, why? Because you don't find that compiling code is that here I have already compiled my FPGA code, so that if you want to make any changes, since I made some changes, how I did there is that I just took some more analog in, I have taken some more analog out, and since I made some changes, I need to start compiling it once again. But whereas in this VA, I didn't make any changes. So if you compile your code once, that is more than sufficient, unless and until you don't make any changes. Since in this chassis temperature.va, I didn't make any changes, so every time I run it, it will start its execution. Now what, I'll just stop this. Now what happens here is that this VA particularly, it is running in FPGA mode. There is one more mode that is called as a RT mode. The main thing in FPGA mode is that during runtime you can't change anything. In case if you want to change, now consider I want to replace this chassis input outputs by some other IOs. So what I will have to do, I'll have to redo this, save it, and then start compiling. The moment it starts compiling, right, I'll have to redo all those. So it will take, say, another 5 to 7 minutes. So what I'll do, there is one more thing called as my RT. So what I'll do, I'll just open a new way under RT module, right click. So this VA is nothing but, this doesn't work in FPGA mode. This works in my RT mode. So what I'm basically doing here is that I'm just trying to call this particular, I'm trying to access actually this particular chassis.temperature VA from FPGA VA into RT VA. I'll just show how to do this. All I want to do is that I'll just remove this from a project. So what I'll do, I'll just go back, go to my SBRIO, right click, I'll open a new VA. Then what I'll do, since I want to access the VA that is present in my FPGA mode, actually this chassis temperature.va comes under FPGA mode. This untitled 18 doesn't come under FPGA mode. This comes under this target, that is my RT SBRIO. So what I'll do, I'll just Control T and I'll just save this as under desktop. I'll just go for SBRIO. I'll just save it as chassis 1 underscore RT. I'll just save this. Now what I'll do, since I want to call the VA that is present in my FPGA, I'll just go right click, go for my FPGA interface. I'll go and give this. Now what I'll do, I'll just double click. I want to tell which VA I want to choose. I'll just go for this VA. Here it will give me the VA that are present in my FPGA target. So since I don't want this FPGA.va, I want to call this chassis temperature.va. I'll just go click this and give OK. And I'll enable this run the FPGA.va. The moment I am given with this, you can see initially it was written as no target. Now it is written as FPGA target. Now what I'll do, I'll just go to the same place, FPGA read or write. I'll just give this to this. Now what happens here is this particular VA will give the reference out to this, stating that this is trying to read the VA from this. So what will happen is that the moment you click here, it will tell you which you want to read, say chassis temperature. So for that what you can do, right click, create an indicator. So now what I am doing is that I am trying to read a VA that is from my FPGA target into my RT target. So what I'll do, I'll just give Control T. I don't want my system to run for only one time. I want it to run for continuous. So I'll just go give a while loop. Right click, create a control, and even I want to see a graph indicator for that. So what I'll do, I'll just go for graph and I'll go here. Now this is done. this will give me my digital display, this will give me a graph. So what is done, I'll just save this. The moment I run, so it will do all this. Now you can find that it is varying as accordingly to that. Now what I'll use, I'll just change my access values, say 1. You can see it is varying from say 1.5 to this one. Now what I'll do, I'll just compare this both the VAs and tell you now. Now the moment I run my VA, now you can just find, even though this my FPGA VA doesn't run, my RT VA runs. So the plus point of RT at real time is that you can parallelly change your data in your real time. But whereas in your FPGA VA, if you want to make any changes, you have to make it and you have to recompile it. But whereas in your RT, that is not the case. Example, actually what I am trying to do here is that this directly takes the VA that is present in my FPGA under this target, and I am telling, and I am giving it to read. So read or write control. Actually what I am reading, I am trying to read the temperature of my SBRIO. Obviously it is a read, not a write. So what I am telling, this gives an input to this. It is from the VA FPGA target RIO 0. Under this I have chassis temperature, waveform chart or stop. I'll just go for a chassis temperature because here I'll be able to see my chassis temperature. Then I'll go create a indicator. This will give my numeric display. This will give my waveform chart. Now what happens here is that whenever you are trying to access any VA, you have to enable this run the FPGA VA. In case if you don't enable this run the FPGA VA, what you have to do here is that you have to run even your FPGA VA once, then only you will be able to access your RTVA. Since I have enabled it initially during during my RT time, so whenever I run this VA, it will internally tell whenever he runs this VA, even run the FPGA VA. But obviously you won't be able to see. Example, I'll just show it here. Now my chassis VA is running, that is under my RT. When I open this, my here you can find my only real-time VA is running, but whereas my FPGA VA is not running. Even though it doesn't run, it internally runs. So based on that, this particular RTVA tries to take the data that is present in my chassis temperature. This gives a data based on a sensor that is present on my board. So this is how you can make your system a standalone. What you have to do is that the VA that you want to run under FPGA mode, what you have to do, right click, go create a new VA. And if you want to have it on your RT target, you have to go right click, create a new VA. So whatever VA that you create in my computer, that becomes your host. Say I can even create it here also. So that becomes your host. This can't be able to run it in your processor. But whereas these two, what I'll do, I'll just right click, create an VA. So whatever VA that I want to run it in my FPGA mode, I'll create a VA under FPGA mode. The one I want it to have in RT. Example, see here I have a VA that is chassis temperature.va. Here I have created a RT for this. Why? Because during my runtime in my FPGA I won't be able to change my values. But whereas here I'll be able to change my values. And this is how you can dump your code into FPGA processor and make it as a standalone. Since you are connecting your SBRIO on a network, you will be able to access it anywhere from this. And this is how you can just compile your code and debug into your DSP processor, and you can do even one of the application. What you can do is that you can just even do your robotics control or your image processing, depends on the application. And always try to maintain that voltage that you supply to analog in or analog out shouldn't be more than -10 to +10. Always try to maintain less than that. When you go for your digital IOs, it shouldn't exceed more than 3.3 volts. Please keep this in mind, and you can just, based on the application, you can set your inputs and outputs. Thank you. Thank you.